Very warm good morning to this session on blockchain in business. So, the session on blockchain in business is being delivered on iNurture, Galileo, and HETIC platform. I am Dr. Rajesh Kulkarni, interacting with you today on this topic. Interacting with you today on this topic. There is a housekeeping request. There may be a delay of 4 to 5 seconds when it is live on Facebook. If any issues in audio video screen, do ping me in the chat window, wherever, whether it is in Facebook or wherever you are connected to me through whichever platform. So guys, this is the topic, blockchain in business, which is an emerging, trending technology. This people are predicting is going to be a game changer, is going to be the biggest disruption. And the prediction is that in another 5 years, 10% of the GDP of the entire world population will be under blockchain. So the visibility of blockchain in various businesses is being seen nowadays, be it any industry. So let us start with the session. So these are the learning outcomes after this session. We are going to introduce blockchain technology. Why blockchain technology is important in today's context? Growth and business opportunities. Where blockchain technology is being used and will be used, be it telecom, hospitality, travel, sports, luxury. Hopefully, it will also help students who are exploring this as a career choice to make their decisions in favor of blockchain. I think you're seeing some images on the screen. And these images, among this, let us try to identify this person with specs. And there is a big link of this person inspects with the word blockchain, our today's topic under discussion. And with this logo, some logo is there and these kind of receipts. So this person name is Satoshi Nakamoto. He is supposed to be the inventor of Bitcoin. And Bitcoin is a peer-to-peer decentralized cash system. Bitcoin is a currency. Bitcoin is a currency. Bitcoin is a cryptocurrency, and Bitcoin is a peer-to-peer network based. Bitcoin is a decentralized mechanism. Bitcoin is created using blockchain technology. Bitcoin is created using blockchain technology. All of us have heard about this, but still for those who are yet to connect with Bitcoin, Bitcoin is just like your money, but the money is digital money. It is not your paper money or cash, rupees or dollars. It's a digital money. Hence, we sometimes call it as cryptocurrency. Sometimes we call it as cryptocurrency. And this person, Satoshi Nakamoto, was instrumental, or was the person instrumental in designing Bitcoin. So there was a huge level of acceptance for Bitcoins. Even if you look at Indian scenario, you might have read somewhere that this X personality, sports personality, or this Y personality from movie industry has got these many Bitcoins and so on. So this is a digital exchange. This is a cryptocurrency. But it is very interesting about this person. The identity of this person by name Satoshi Nakamoto is still a big secret. We are not sure who this person is, or this is a pseudo entity. This is a pseudo entity created by the creator of Bitcoin or the creators of Bitcoin. They feel that this technology revolution was not done by a single person, but there may be multiple persons involved. Hence, there may be a group of persons, there may be a group which had initiated this Bitcoin. So is Bitcoin and blockchain same? No. Bitcoin is based on blockchain. Bitcoin is based on blockchain. And this regarding Bitcoin, Satoshi Nakamoto had written a paper. I'll just share you that paper. Hopefully it is visible to you. Usually it takes a bit on Facebook. That's why I'm delaying. Yeah. So what you are seeing here is the paper by Satoshi Nakamoto. This is the website. It is visible, bitcoin.org. And the title, if you look at the title, Bitcoin is a peer-to-peer electronic cash system. Bitcoin is a peer-to-peer electronic cash system. So cash as in money, and this is electronic as in digital. So you have digital money system by name Bitcoin and created by Satoshi Nakamoto. I request those who are interested in blockchain, they can start reading this paper. They can start reading this paper. I'll just try to highlight few of the keywords from the abstract of this paper. For example, it's a peer-to-peer system, as in there is no centralized system. There is no centralized system. What is a centralized system? Centralized system, as in there is a server and everything is kept at one location at the server. While in the peer-to-peer network, it's distributed and all the peers, all the nodes are equally capable, have equal rights. So that is what is the meaning of a peer-to-peer network. And I'll highlight the next word as electronic cash. Next word I'll highlight as online payments. So you'll be doing online payments using Bitcoin to do few purchases, But very interesting thing, there is no involvement of financial institutions. There is no involvement of financial institutions. Meaning what? Meaning, suppose I have some money and definitely I'll be keeping that money in various banks. And if I want to do some purchases like online purchases, be it Amazon or anything, I know that I can do electronic transactions. But I also know that for everything, I have to pay to the bank. If I'm using my ATM card, maybe some percentage I have to pay to the bank. If I'm using bank to keep my money, maybe some percentage it will be used. So some percentage will bank for the services. Some percentage will go to the bank for the services. But with the Bitcoin and later on with blockchain, the major disruption is there is no involvement of financial institutions. There is no involvement of financial institutions. So we are removing the in-between people, what we call in our generic terms are agents or in-between people. We are removing them. And that way we are saving a lot of money and we are saving a lot of time also here. So here what disruption had happened was with digital currencies, one major challenge was double spending. And that double spending was a flaw. For example, I have a digital currency, so it can be duplicated and I can, same money I can spend twice. So that was the challenge. So this challenge was overcome by Satoshi Nakamoto, the pseudo name or persons who call themselves Satoshi Nakamoto, or firms or group of people who call themselves Satoshi Nakamoto, had resolved this problem of double spending, and that POC they have shared here in this paper. So I recommend all of you to read this paper to increase the knowledge curve in this domain. So let us go back to our PowerPoint presentation. Let us go back to our PowerPoint presentation and let us look at this. What we are able to see here is Bitcoin Genesis block. This was the first block which was created by Satoshi Nakamoto. So what you are saying is there is something hidden here, is it not? There is a hidden message, hidden data. So in technical terms or in computer terms, something is hidden means what? You have encrypted it. You have encrypted it means what? You have used cryptography. You have used cryptography means what? Either you might have used symmetric cryptography or you might have used asymmetric cryptography. So, but we know that Bitcoin and blockchain use asymmetric cryptography, and specifically they make use of SHA-2 algorithms, SHA-256. So these kind of algorithms. So here they use in that SHA is secure hashing algorithm. SHA is secure hashing algorithm. So what we are trying to convey through this image is this is a digital currency, and this digital currency, or rather digital data. This digital data is hidden. This digital data is hidden. How it is hidden? By using a hashing, hashing algorithm. So you are using some hash, you're using some hash number to hide this data. You are using some hash number to hide this data. So the story goes that the initial bitcoins created by Satoshi Nakamoto were never spent. The others came in the picture, and there the electronic transaction started. But these, as they have a legacy, they were not spent, but they have a huge value in terms of ROI or what. So coming to our basic topic, blockchain. So what we can say regarding blockchain is, blockchain was basically used initially for creating Bitcoin cryptocurrency. But what is blockchain? At least we know that there are two words in the blockchain. There is a block and there is a chain. These are the two words. So there may be multiple blocks and there is a chain of these multiple blocks. And a block, what a block consists of, you can treat as a block as some portion which may be having data, which is a secure data. So a block may be having data, a block may be having secure data, and you are linking multiple blocks together. A chain is formed. So that is your blockchain. So to make it secure, and to make it decentralized, to make it publicly available, you are using what? You are using peer-to-peer network. First thing, you are using peer-to-peer network. Then you are using the hashing technique, and specifically you are using the SHA algorithm. There are other algorithms also like MD5 for this hashing here, but we are referring SHA, and that too SHA1 was the predecessor. SHA2 is the afterwards, and SHA2 is a collection of multiple algorithms, and one of the most famous SHA2 algorithm is SHA256. This is what it is showing now regarding blockchain. A blockchain, as I said, it's a collection of lot of blocks. Each block may contain some data. So you can treat this blockchain as like a accountant's ledger. Suppose there is a bank. In the bank there is a ledger, right? And what is a ledger? Ledger consists of lot of records of transactions. So now what you can say is, this is blockchain is nothing but this is a digital ledger. Blockchain is a digital ledger which is publicly available. And it uses peer-to-peer network. It is distributed. It is secure and trusted. And immutable. So how it is made secure and trusted? With the help of peer-to-peer network, and with the help of hashing techniques, with the help of algorithms like SHA or MD5. Now, what blockchain has done is, it has classified, generalized, and adapted to new situations. Hence, it is available for multiple verticals, multiple domains, multiple industries. And the story says that till now, blockchain is unhackable. So you see a lot of stories, lot of news, lot of videos regarding how hacking happened. You might have seen the bitcoins being hacked, or you might have seen hacking, very famous, that ransomware WannaCry. So such examples you might have seen, but till now nobody were able to hack a blockchain. So these 2-3 slides, what they tell us regarding blockchain? They say that blockchain is a service for digital transaction. And all those digital transactions are recorded on a ledger. And that ledger is a digital ledger. That ledger uses peer-to-peer network distributed systems. Uses peer-to-peer network distributed systems. So let us now highlight this word. Let us now highlight this word. Centralized ledger versus distributed ledger. But in this, at least we have heard the word ledger, and we said ledger consists of records and record of transactions. Take for example this diagram, the left diagram. What the left diagram is saying? The left diagram is saying that you have a bank and you call that bank as a clearing house, and that bank has a ledger of records. That bank has a ledger of records. So at one central place, all the ledger data will be available. All the ledger data will be available. So a typical banking system, But this is the example of a centralized ledger. Now coming to distributed ledger, which a blockchain follows, you see here in the diagram that there is no such central entity. At least from the diagram, we can claim that in a blockchain environment, the central entity like banks or other agents or other platforms which charge for services are being removed. So at least here we have a revolutionary concept wherein the middleman is being removed and the time and money being saved, because they'll also take their time for keeping all the records of all the transactions, verifying them and so on, and charging you for all the services they are doing. So hence they say that blockchain is one of the biggest disruption, along with other disruptive technologies like artificial intelligence, machine learning, Internet of Things, RPA. That's it. So are you able to see here? A diagram? So this diagram is trying to elaborate the concept of a block. So what it is saying is a block consists of a bundle of records. And a record can have some information regarding some contract. Suppose there is a smart contract. Suppose I purchase a house. Suppose I purchase a painting. Suppose I purchase something. So that contract details digitally will be available. That is called as a record. So a block will be having many records. And what is a blockchain then? A blockchain is these many blocks. Are connected together. It's a chain of blocks. It's a linkages of many blocks. Now, the moment I refer the word block, immediately computing people or technical people will raise one point that what is the size of the block? Again, usually we are habituated to some XYZ size, for example, 256 or 512 or 1 or some entity. Initially, when Bitcoin was designed, Satoshi Nakamoto had specified the size 1 MB for one block. The size of the block was 1 MB. But that is there is no reason specified even till now why such size was specified. Can we increase the size? Can we decrease the size? So there is a lot of controversy as far as block size is concerned. So there are different school of thoughts which claim that it has to be fixed, it has to be different, it has to be varying, it has to scale. So on those lines, there is a lot of controversy as far as block is concerned. But conceptually, blockchain is collection of blocks. Block is like a smart contract or smart transaction record. smart transaction record. So as you are able to see here in the diagram, this these are proprietary images, and we are mentioning wherever possible the sources of those images. What you are seeing here is a Bitcoin block example. You are seeing here is a Bitcoin block example. For example, Bitcoin is purchased. A Bitcoin is purchased from Sam by Peter, and the amount is 200. The amount is 200. So this is a transaction. This is a purchase transaction. So this purchase transaction is recorded in a block. Let us say block 2 is recorded in a block. Let us say block 2. So you have a Genesis block. You have a Genesis block, and I had given you the example of Genesis block, a block with the help of that image, which was designed by Satoshi Nakamoto. So as you see, you are having multiple blocks. You are having multiple blocks, and these blocks are linked with each other. These blocks are linked with each other. Now, what you're seeing here is block 1, block 2, block 3, and so on. Now, each block is having a hash, For example, block 2 hash number is 7B2Z. Block 3 hash number is 3DFV, and block 1 hash number is 2ZB1. And at every block there is an entry regarding the previous block, previous hash of the previous block. So this way, now what is hash? We have been repeatedly saying that hash is a hashing technique. Hashing technique is a SHA, derived from SHA, secured hashing algorithm. So it means you are doing some one-way, achieving one-way secrecy, achieving one-way encryption kind of thing. Now hash is some you see here some number is generated here. You see some number is generated. Hash 256, and accordingly it's a 4-byte number. It's a 4-byte number, and it is treated as a fingerprint. It is unique, and it is treated as a fingerprint for that block. It means this block, suppose it is owned by Rajesh, so it has a unique fingerprint. It has a unique fingerprint. Now you see here, every block has a unique hash number. Every block has a unique hash number. Now, but what we did was, we made some change to the data. We tried to tamper the data of block 2. So what resulted was immediately the hash value of that block changed. And you can see the reflection here. The actual block 2 hash value is 7B2Z, but now it is changed to AA23. So this way, a blockchain makes this is tamper proof, or it makes it secure, it makes trustworthy, it makes immutable kind of things. Yeah, we'll see this video for 2-3 minutes max, just to get a feel of the hashes and the blocks in the blockchain. Bear with me. It's a long video, but we are going to see this video for 2-3 minutes. That's it.
This is a blockchain demo. We're going to do this in a very visual way, though. We're going to make it very easy to understand by stepping through the key pieces of what a blockchain is. This is a blockchain demo. We're going to do this in a very visual way, though. I'm going to make it very easy to understand by stepping through the key pieces of what a blockchain is in a visual way. But before we get started, we need to take a look at this thing that we call a SHA-256 hash. Okay, and a hash, this is one of them right here. Hash looks like a bunch of random numbers. And essentially what it is, it's a fingerprint of some digital data. And it just so happens it's the fingerprint of whatever I type in this box. So if I type my name, Anders, into this box, you see that the hash has changed. As a matter of fact, it changed every time I typed a letter, right? So I'm going to go back to, so it says Anders. Okay, so this is the hash of the name Anders, all lowercase. It starts with 19EA, right? Okay, so if I delete that and I go again, type Anders again, you can see it starts with 19EA, the same exact hash. In that sense, it's a digital fingerprint of this data. Whatever data is here, every time you type exactly the same data, you get exactly the same hash. And I can type anything I want. So you can have nothing like this, E3B0, that's the hash of nothing. Or you could type tons and tons of stuff. As a matter of fact, you could put like the Library of Congress in here and you would get a hash. And the interesting thing about it is, regardless of if there's a tiny amount of information, no information, or the entire Library of Congress, you're always going to get a hash that is this long, this many characters. You're not going to be able to pre-guess what this is. You kind of have to put the Library of Congress in here to figure out what the hash is, but you'll always get exactly the same hash regardless of how many times you put exactly the same information in. So what I'm going to do is extend this idea of a hash into something that we're going to call a block. All right, so let's take a look at a block. So this is a block, and it's exactly like the hash. It's just that that data section I've broken out now into 3 sections. One called block. This is just some kind of a number. This is block number 1. A nonce, which is just yet another number. We'll go into what that is in a second. And then just some more data, just very similarly to the way that we had it before. However, the hash of this, which includes all of this information up here, is down here, and it begins with 4 zeros. You see that? And that's a relatively unusual hash. Most of them are not really going to start with 4 zeros like that, but this one happens to. And because, all right, so here's my blockchain. I've block number 1. It has some kind of a nonce just like before. There's some data area to it, but then it has this previous. Here it's a bunch of zeros. Let's roll forward. So this is block.
So what you are seeing here is a blockchain. So you have block number 1, block number 2, block number 3, and the hash value as well as the previous hash value. So this visual representation may make us connect with the concept of blockchain. You are also seeing the data part and the nonce part. Okay, so this nonce part is a specific number which is used only once, like a pseudo number generator, random number generator kind of thing. And this will be used in hash generation. This will be used in hash generations. As you learn further, you will know that the miners will be mining this and they'll be getting some credits for all this. So this was a small video just to connect with the concept. Now we were saying, by looking at this diagram now, we know that this is a blockchain. So you have 4 blocks, and these 4 blocks are distributed on a peer-to-peer network. They are distributed on a peer-to-peer network means, let us say there are 4 networks and all the networks have equal capabilities. So there is no centralized thing or a master-slave kind of concept. And this distributed peer-to-peer network will have suppose the blockchain length is 4, everywhere it is reflected in the same way. Everywhere it is reflected in the same way. It is like this. Suppose there is a bank ledger. Now the bank ledger is not in the bank, but the bank ledger is with every customer, and whatever changes are happening, they are nothing but the addition of blocks. They are nothing but the addition of the block. So if some customer wants to tamper with the data, so that will immediately be reflected with, because the hash will change, and that's how the secure and trustworthiness is brought. So there is a consensus. There is a consensus among this peer-to-peer network, which brings the trustworthiness and security. If you look at this diagram again, brought from educba.com, you will be looking at few of the applications of blockchain. So one we have been seeing Bitcoins, the other we can see for voting, one online payments, online transactions, one for sales, renting, real estate, means you can have smart contracts. You can have smart contracts. Banking, as we said, the central banking authority is being removed from this in this concept of blockchain. It can be used in law enforcement for all the digital documentation, digital IDs. So many of the countries like South Korea, Australia, they're using blockchain for digital IDs. They're, for suppose you want a license, or you want some ID card. For example, we Indians have the habit of Aadhaar cards and voter ID cards and licenses and so on. So all those have the possibility of blockchain being brought in, and all those physical papers being taken away, and they'll be replaced with this blockchain digital IDs. So that is these are few of the applications of blockchain. Now we'll be taking few case studies in blockchain. For example, one of the case study in blockchain is telecom industry. And with the telecom industry, we all use mobiles, we all use phones, we all use different SIM cards, we all use different service providers, and we also face many challenges. Sometimes the signals are not proper. I want to do porting of the number. I have some service issue. I get a lot of spam calls from banks or fraudsters or from marketing guys. So all those services and all those challenges are being addressed by the distributed ledger technology from blockchain. Okay, so telecom industry pan world is adopting blockchain to overcome all these challenges of spam calls, messages from marketing, number portability, so bringing transparency in KPI. So, yeah. So how they're using is, again, they're using a SHA, MD5, and they're safe. Again, 1 or 2 minutes, we'll look at a video.
Blockchain use case for the telecom industry. Blockchain technology disrupted some of the biggest industries in the world.
I'll take
like
up to 2
finance,
minutes.
banking, international remittance, and
Just
supply
to
chain
understand.
management, to name a few. This is a testament to the fact that blockchains offer radically new ways of conducting business. Blockchains bring them the primary benefits of trust, security, transparency, and autonomy across all nodes participating in the network. One of the most important things for telecom companies is to innovate in a highly competitive market while at the same time reducing costs. Here are the various aspects of the telecom industry that can benefit from blockchain technology. Internal telecom operations. Second generation blockchains like Ethereum bring with them the revolutionary smart contracts. This allows for computer code to execute on its own when certain conditions are met. This has an especially important appeal for the telecom industry as it provides a lot of automation in their internal operations like billing, roaming, and supply chain management. By using smart contracts to handle all of the billing related to roaming, telcos can save a lot of money because of prevention against fraudulent traffic. Currently, transactions within the telecom company's ledgers have to go through a clearinghouse to be authenticated. Using smart contracts can automate this process so that none of that post-processing is required, which saves time for the companies. In doing so, telcos also save money by spending less on auditing and accounting as the process is automated. Developing new digital services. Telecom companies can provide a host of new blockchain-related services to their customers, which can lead to new revenue streams for the companies. Some examples include digital asset transaction. Telecom companies could leverage the cheap payments done using blockchains to enable micropayments for music, mobile games, and other such services. Telecoms companies could also use blockchains for customer-to-customer money transfer services. India saw a lot of telcos moving to this model after demonetization in 2016. For example, Airtel and Jio, India's leading telcos, both offer their digital wallets to enable customer-to-customer payments. By employing blockchains to handle the transactions, these companies can make their wallets more secure and cheaper. The international remittance market is a multi-billion.
So that was blockchain in telecom, which is the video highlighted various applicabilities in the telecom industry. The other industries, as I mentioned, for example, few countries are adopting blockchain for paperless driver licenses, ID and proof of age. Few countries are adopting digital currency. For example, this is a Wipro project along with R3 for digital currency in Thailand. There are 8 banks and few number of entities which are coming together for adopting the digital currency. This was a news in 2018. Maybe it has come into picture now. Coming to use cases in travel industry, we all know that presently the COVID-19 has affected the travel industry most. But the travel industry or the hospitality industry also have a use case of blockchain, in the sense you can make all the bank payments securely. You are going to eliminate third-party costs. Actually, in the travel industry, it's a bit disruptive in the sense the in-between agents will be totally thrown away. So you'll be ID and security, loyalty programs through digital tokens, baggage tracking, resolving logistic challenges. These are few of the case studies or use cases in travel industry adopting blockchain. Now, any companies which have adopted blockchain, yeah. For example, TUI, then there is a blockchain platform for renting property, then there is TripKey loyalty reward program. I just mentioned few of them, but if you just check it out, you see thousands of them going for this. So I'll just go through these videos for one minute each to understand adoption of blockchain by the travel industry.
We're surrounded by digital transactions, millions and billions of them. These transactions form the foundation of our society, and they're at the point of being revolutionized by a technology called blockchain. Blockchain is a decentralized encrypted database shared across a network of stakeholders where digital transactions can be stored and organized in a transparent, verifiable, and secure way. Information added to the blockchain has to be validated by consensus, accepted by all parties, rather than by one central administrator. This reduces errors, as there is no single point of control. Each block of information added to the chain is time-stamped. This ensures that the information is auditable and traceable at any time. Most importantly, blocks added to the blockchain can never be removed or modified, eliminating the risk of data tampering and fraud. Blockchain is a young technology, but it has the potential to disrupt the way business is traditionally done. At Amadeus, we're already investigating the impact it can have on the world of travel. For example, payments. Making settlements between different parties, like hotels, travel agents, and aggregators, can be an extremely complex process, especially across borders. Blockchain could streamline this process by reducing the intermediaries and the settlement timing while increasing the overall flow transparency. Traveler ID verification. Today, travelers are required to show their ID at multiple stages of the journey, from booking to boarding to checking in at the hotel. Blockchain could make this more secure while simplifying traveller identification at every stage. Baggage tracking. Another challenge is keeping track of travellers' luggage, as it changes hands from airlines to ground handlers at airports. Blockchain will allow all parties to exchange information, even if they are not in the same alliance or related to the same segment, improving the accuracy of baggage tracking across the industry. At Amadeus, we believe we are only just starting to see the possible applications of blockchain.
Let us take one more video for 2 minutes.
Let's walk you through a blockchain identity travel use case. This is Bob. Bob is a frequent business traveler. Every business trip is constantly delayed by delays at the check-in counter or the baggage drop-off counter. Long security check-in lines, passport and/or visa verification, and border control checkpoints are no fun. Bob is very frustrated with the checks in place today. What if there was a more convenient way to travel? What if the check-in process was completely self-service and there were no longer long lines? Blockchain identity solution will revolutionize the way we travel today. Blockchain identities integrated biometric authentication service combined with verified digital identity solves the complex challenges of travel. Here is an example of how the check-in process would be in the future. Bob downloads the Blockchain Identity app and has his identity verified and trusted in the app. Next, Bob checks in for his flight online or at the counter and takes his boarding pass to the security kiosk. Bob has to verify his identity using biometrics either through a facial recognition or voice biometrics. A QR code is generated and Bob scans the QR code with the app. Once verified, Bob's information is sent to the security kiosk and the security gates can open for him and he can go through security screening. Passport verification, visa verification can all be streamlined using blockchain identity and eliminates long lines and long delays. Bob is a happy traveler now. Now let's go through how this works. Bob's information and all trusted IDs are used to create his self-sovereign ID. This ID has levels of assurance that are tied to it. The more the LOA, the better, the faster the process is for Bob. When the boarding pass is available on Bob's mobile device, it is downloaded to the identity vault of the blockchain app. At the kiosk, Bob has the ability to share his self-sovereign ID for check-in and a QR code is generated. For verification, biometrics are used to ensure that Bob is the person traveling. Once verified, the kiosk gates open and lets Bob in. And that's how blockchain identity will change the way we travel in the future.
The use cases in sports are sportsmen's smart investment contracts, managing ticket sales and prevent counterfeit ticket sales, eliminate middlemen, regulate transparency in drug testing. So we all know doping is a major issue. So when you bring transparency regarding the testing agencies and regarding the sportsmen being tested, which is publicly available, then it controls a lot of negativity and a lot of problems related to doping in sports industry. So as you can see, whether it is sports, whether it is travel industry, whether it is governments, whether it is banks, so you have, whether it is telecom, so the various use cases indicated that our lives post another 4 5 years will be totally disrupted by blockchain. So we all are looking forward to blockchain, and one small message to all the community, teaching and learning community, be it students, be it teachers. So let us gear ourselves for improving the learning curve of blockchain through various courses, be it online, be it from some universities. If you see, there are many universities which are offering blockchain as a course in their undergraduate or postgraduate. For example, nowadays, BTech computer science, a specialization in blockchain, or MTech computer science, specialization in blockchain, or you have various online learning models from Edureka or any other platforms where blockchain is being offered. Even there are private entities which are collaborating with universities. Even there are private entities which are collaborating with universities for these kind of courses. So guys, this was it as far as the topic blockchain in business is concerned. The objective was to sensitize people regarding blockchain, gear up regarding blockchain, and any questions you can always reach out to me through my mail or through any other social media platform. So guys, that's it from today. And this session will be recorded. The session contents will be available also on SlideShare. So happy learning to all of you from Dr. Rajesh Kulkarni. Bye. Shweta, I think I am done for today.
Thank you, Dr. Kulkarni. It was a wonderful session. If any of our viewers have any questions, please post them in the chat section, and Mr. Kulkarni will be able to answer them. Please make it quick, and 2 minutes. If you guys have any questions, please go ahead. Okay, looks like we do not have any questions for today. Guys, if you have any questions later also, if you are studying blockchain in detail, and if something crops up in your mind that you would like to ask, you can always go to our Facebook page. This session was also live on Facebook page. You can perhaps comment under that live section recording, and then we will make sure that we get you an answer from Mr. Kulkarni, who is an expert in blockchain. Thank you so much, everyone. Thanks for attending today's session. And please follow us on Instagram as well as on our Facebook. The page name is HETIC India on Instagram as well as on Facebook. You will be intimated about all the future sections that we will be conducting on various technological as well as inspirational topics. Thank you so much. Have a good day, everyone. Thanks, Dr. Kulkarni, for your time again.
Thank you, Shweta.
Thank you. Bye-bye.